Okay, guys, listen up, please. We're started already. Today, what we're going to do is simplifying expressions by combining like terms. So we've got quite a bit of vocabulary that we have to go through at the start of our lesson here. So just hold on as we get through the vocabulary. When addition or subtraction signs separate an algebraic expression into parts, each one of those parts is what we call a term. So we used that word the other day without giving you the full definition. There it is. It is the parts of an algebraic expression. The numerical factor of a term that contains a variable is called the... David, you are going to lose your chair today. That's two already. What do we call the numerical portion of a multiplicative algebraic expression? It has a special name because we're now using it in a multiplicative algebraic expression. What is that special name that we give it? No. Thank you, Devin. Wow, Sean, I'm really surprised you let him beat you on that one.
Wait, I thought coefficient was...
Coefficient, the numerical factor of a term that contains a variable. A term without a variable, if there is no variable, what do we call that? It's just a number. What is the mathematical term for it? No. Factor means I'm multiplying. What do we call it? Sean? What do we call it? A number that is by itself. In other words, it's the one you tried to say last time. Called a constant. Now this is one we haven't really talked before, so we'll just put it up here. Like terms are terms that contain the same variables, and that's really the key on this, or lack of variables. If it's all constants, those are also like terms. Okay? So if I look at a algebraic expression, in this one we have three terms. Our three terms are the 3x, the 7, and the x. Make sense? Three pieces, all separated by addition signs. Like terms are the ones that have the variable. That's the 3x and the x. The 7 is what we call the constant. Does that make sense?
Are they going to drive us insane by not telling us what X is?
Yes. We will not know what they are today. You're not going to be able to solve anything today. All we are doing is putting together the like terms. Okay? Now, I want you guys to go ahead and take a minute to fill in our three bubbles on this side. Fill in the appropriate terms. The first box is what? Terms? Yes. So the three arrows go to the terms. The one arrow going just to the 9, that is called the what? The constant. The two arrows pointing to the numerical portion of those are the coefficients. Because it's pointing to specifically the underlying piece. If it was doing the whole thing, then it would have been like terms. Make sense? But because it was just the numerical portion, then it's talking about the coefficients. Is this vocabulary starting to resonate with you? You need to understand the vocabulary because this is the stuff that will be on your next quiz. Okay. Then just hold on and we'll figure out as we go along. Okay, our next one. To simplify an algebraic expression, use properties to generate an equivalent expression with no like terms or parentheses. In other words, I want to get rid of all the parentheses and put everything together that I can. In other words, everything that is the same. The same constants, the same variables. So if I have x plus x, I would rewrite that as?
X squared. I have no clue. X squared or
Say it again, Caden. 2x.
X squared is multiplying x times x.
Yep.
You're adding x plus x, so you just have two x's.
So as a quick reminder, if I do not see a coefficient in front of my variable, what is that coefficient? Because it's actually there, we just don't show it if it's a certain number. Liam?
0. What if you wrote it kind of like an x?
That would be wrong.
Times x.
You're adding them, 1x plus 1x, and that gives you 2x's.
Oh, those of you that just listened to Miss McShann, she just gave you the answer. No, it's not. I said if I don't see the number in front, the coefficient in front of my variable, what is it?
0. Wait, no. It's 2, isn't it?
It's a 1.
Yay.
If I don't see the coefficient, it's a 1. Why? What is 1 times x?
X.
What property says that?
Identity property of multiplication.
Kind of right, but you're messing it up.
That's identity property.
No.
Identity property of multiplication. Oh wait, is it multiplicative?
Boy, those little birdies sure are busy around here, aren't they, Miss McShann?
Oh, wait, sweetie, we're good.
Multiplicative.
Property of multiplication.
You missed a word. Identity.
Oh, multiplicative identity property of multiplication.
No. What number did we just talk about?
1.
1.
Oh, 1.
The multiplicative identity property of 1. 1 times any number is itself.
That's 2.
So this is one of the very few shortcuts we consistently use in mathematics. If my coefficient is 1, we normally just don't show it.
That's too many words though. Now that's more identity property of 1.
Now when you start to, wait till you get to geometry and algebra. Geometry is like almost 0 numbers. Geometry is all about words. Words and logical processes.
6.
Okay, what about 4 times 6x?
4 times 24x.
Sean? Sean?
24x.
Well done, Sean.
You didn't look at me like
Because, what does that mean? It means I have 4 groups of 6x's. So how many groups of x's do I have? 24. So,
look at me like I'm gonna murder you.
guys, come on. 2 expressions are equivalent when the expressions have the same value, no matter what that value is. So what I'm doing is putting together the pieces that I can. So if I have 3 times x times 11, how could I simplify that by putting these pieces together? What can I put together? 3 times x times 11. Which pieces could I put together? Sean?
Would it be 33 times 11x?
No?
There are no
You
like
would put together 11 and 3 and 11 and x?
No.
multiply them.
How can I simplify this? What can I put together? 3 and x. Is there anything else I can put in there? 3 and 11. How do I put 3 times 11 together?
33. Oh wait,
Yes, it literally is that easy.
I just said that.
33 times.
No, you said something about 33x plus 11x. I thought you had it, and then you put the 11x back in there. Yes, I can just multiply the constants. 3 times 11 is 33 times x. What's depressing? Devin, you got this one. We talked about this one before, commutative property of multiplication, right? If I'm multiplying all the numbers, can I switch them around? Yeah, 3 times 11 is
33.
times x. I don't know what x is yet, so I can't go any simpler than that, so it's 33x.
33.
Oh, because x doesn't have a coefficient. So you wouldn't.
33.
Technically it does, its coefficient is 1. Remember, technically it always has a coefficient. Okay, what about our next one? Part B, what would I do?
X times x.
No. 3x. 3x. It's 3x.
is not x times x. That would be x squared.
3x.
It's 3x.
I'm
Okay, what about our last one?
Guys, all the underlying talking and noise needs to stop, please. Thank you.
I'm thinking this isn't working so well. I'll let Mr. Chan take a look, but if you guys aren't both completely caught up with everything on the paper, one of you is moving. Okay, what about our last one? What can I put together?
x and x, so x or 2x. You can do 7 plus 8 plus 2x,
So that would be what?
15x. Or 15 plus 2x.
Everybody good with that?
Someone was even a little ahead of us.
Does that make sense to everybody?
Yeah.
Then why are you all so wrong?
Is it 30x?
No, it has to be 17x.
Again, we're looking for like terms. Which terms are alike? X and?
Oh, 7x.
X and 7x. So if I put those together, what do I get?
7xx.
I'm
adding, not multiplying.
Okay, so if I have 7 x's over here and I have 1 x over here, how many do I have when I put them together?
8x plus 8.
Honestly, guys, is that hard? I have 7 x's here. I've got 1 x here. I put them together. I have 8x.
No, it would have made more sense.
I just don't have as much wiggle as Mr. Chan does for doing that one.
8 times plus 8.
Okay, now I want to take a step back because we just did distributive property last class. The opposite of distributive property is what we call factoring. So is there a common factor in those that I could take out?
8.
8. So I can rewrite that as 8 times what?
Times 2. Wait. 8 times 2.
No. 8 times 2 is 16.
Right.
X plus
8. Wait, no, not 7.
Wait. Rowan?
7.
X plus 7x. I don't know. What are you doing with the 8?
what am I doing with the 8 on the outside?
You're multiplying.
Multiplying to each of the inside, right?
Wait, it was Wait, really? Yes, because you multiply it.
Because now if I do distributive property, I distribute the 8 back to the inside. 8 times x is
8x.
8x plus 8 times 1 is
8.
I was joking, but okay.
So was he right?
he was right.
But not on purpose.
I know.
Where's this evil competition you do that? It was subconscious thinking.
No, yeah, right, sure.
Okay, now we get a word problem. This is where we get fun. 3 friends are going to pay X dollars each for admission to the museum, plus $1 each to view the mummy exhibit. A 4th friend will pay admission, but will not view the mummy exhibit. Write and simplify an expression. There's our task that represents the total cost. So what is the first part of our expression?
Uh, 3x plus 3, wouldn't it be?
Well, that's one way to look at it. I could say 3 friends are doing what?
Paying admission.
Which is, and what?
Plus 3, or plus $1 each to pay the mummy exhibit.
Okay? And what's the other friend doing?
He's paying the admission, but not for the mummy.
So how do I represent that?
X.
Is everybody okay with this?
No. Because it's $1 each for the mummy exhibit.
Right, so if you
Right.
multiply that 3 times 1, you get...
So let's distribute our 3, because we wrote it as 3 of the kids are doing both the exhibit and the mummy. So that total gives us 3x plus 3 plus x. Is everybody okay with that?
No.
You said no, Liam?
No, 3.
We circled it. It's right here, 3.
For admission and the museum. And 1 friend will only pay for...
Sean?
Or you could do 4x plus 3.
because I can combine my like terms,
Yeah.
3x and x.
I was just thinking about that.
Yeah, sure did.
I was actually thinking.
Is this making sense?
No, not about.
Why not?
Guess what?
Think about our combos yesterday.
For you.
You have admission and you have the mummy exhibit, right? 3 people are doing this. He wrote it as 3 people are buying this combo. Remember? And then 1 person is only doing this part, so it's plus that part. That's basically what he just wrote on the board.
Make sense? Well done, Miss McShann.
No, that wouldn't be right. The answer is not 7x.
No, it's not. Those aren't like terms. That's a constant. Can't put a constant together with a variable unless I'm multiplying. But I can't add them together. Okay, now properties can use, guys, we can also simplify expressions with 2 variables. The number of variables really doesn't matter. I'm only looking for the ones that are alike, the like variables. So on the first example here, what's the like?
X, so it'd be 2x plus y. Finally.
Does anybody not see that? Again, the big factor being we're now adding versus multiplying. Now our next one, we're looking at distributive property again, right?
Yeah.
So the first thing I need to do is distribute my 4. So what does that give me?
8x and 4y. 8x plus 4y.
Does that make sense?
Wait, no.
Why?
How'd you get 8?
You did 4 times 2.
4 times 2. So what did you,
Because we distributed the 4 to the inside terms. Okay. We'll give you guys 1 minute. Finish the box. Okay. First one. What did you guys get for A?
36y plus x.
Good. 36y plus x. Part B.
5x plus 9y. 5x plus 9y.
You can't answer C. That's my answer.
C. John?
21x plus 7y.
Well done. You guys got all 3 of those. Hopefully you got those 3. Okay. So for our home, that's the end of our notes. We're going to do an in-class activity. Okay, your homework is actually relatively simple today. It's a lot of what we did in class where you're just simplifying the expression. Again, put together the pieces that go together. Do pay attention whether you're multiplying or adding. That's going to change how you're going to do it. A couple of word problems. The challenge ones, if you don't get to, we're not going to stress on because they really are pretty tough. The back side on the maze, it's just like all the other mazes we've done. Again, your work is basically just showing us what you're combining. In this case, I've got 7x minus 3x is 4x plus 1 minus 6. Should be a minus 5. That's interesting. Oh, because that's not the start. Pay attention to where the start is. There's a hint. I was wondering why that worked out. Okay, so we have 5x. Minus 6 plus 5 is just a minus 1. So 5x minus 1 means I'm going to end up going that way. You just keep going around until you get to the end. Good luck, guys.